All right, so we're moving into our last topic in our transformations unit, and the topic is called inverses. All right, so what do we mean by a mathematical inverse? So mathematical inverse is a transformation that maps f of y equals f of x to x equals f of y. So what's happening here, if you have a point on your original graph, which is x, y, what's happening is the x and the y coordinates.
Now I'm looking for the grade 12 M, N, and O to head to the cafeteria, M through O to the cafeteria, grade 12.
The x and the y values are going to be reversed after an inverse happens, okay? So, all right, so for the first part over here, given the graph of y equals f of x, sketch the graph of x equals f of y. So I'm just going to do a quick little mapping notation over here for this question here. We have the points -2, -5. We have 0, -4. We have 2, -3. We have 4, -2. So these are the points that we have. So what happens is this guy becomes -5, -2. This guy becomes -4, 0. And then -3, 2. And then -2, 4. Okay. So plotting these points, we have -5, -2 is here. And -4, 0 is here. And -3, 2 is here. And -2, 4 is here. So we're getting this graph here. Okay. All right, so for part A over here, state the domain and range of y equals f of x. So we're looking at this blue graph here. Our domain goes from -2 to 4. Our range goes from -5 to -2. Now looking at my red graph over here, which is my inverse, state the domain of x equals f of y. So this is the inverse function here. Our domain of the inverse is from -5, starting here at -5, ending at -2. The range goes from -2, ends at 4. So hopefully what we're recognizing here is that the domain and range are the same values, but they're just flipped, which makes sense, right? Because like if we're flipping our input and our output values, or our x and our y values, well, the input, the domain, which is all of the inputs, becomes all of the outputs because they're getting switched and so forth like this. So generalize what happens to the domain and range of y equals f of x and x equals f of y. The domain becomes the range, and the range becomes the domain, right? So it's like we're switching our input and our output values. So for part D, it says draw the line y equals x on your grid. Make a generalization about the graphs of y equals f of x and x equals f of y. So y equals f of x is just this diagonal line passing through the origin. So this is when x and y are the same values. It's going to be along this line over here. And if you tilt your head to the right a bit over here, hopefully what you're seeing is that this blue graph is a reflection over this line and becomes this red graph over here. Okay, so what we're trying to get at for this last bullet is y equals, so x equals f of y is a reflection of y equals f of x across the line y equals x. Okay, so we reflect it across this line and we get this function over here. Okay, example 2. Given that f of x equals x squared minus 1, sketch y equals f of x and x equals f of y on the grid below. Okay, so here's what x squared minus 1 is going to look like. We're going to have a vertex at 0, -1. 1 squared is 1, so we're going to 1 up like this. 2 to the right, 2 squared is 4, so I'm going 4 up from 1, 2, 3, 4. 2 left, up 4. If I go 3 to the right, 3 squared is 9, so I'm coming up here. And then -3 squared is 9, I'm coming up here as well. So here's my graph of y equals f of x. All right, now sketch x equals f of y. So if I have this point, which was -3, 8, it's going to become 8, -3. This point, which is -2, 3, is going to become 3, -2. So we get 3, -2. This is -1, 0. It's going to become 0, -1 here. This is 0, -1 becomes -1, 0 here. 1, 0 becomes 0, 1 like this. 2, 3 becomes 3, 2. And 3, 8 becomes 8, 3. So this is going to be our inverse relation here. What are the x and y intercepts of x equals f of y? Okay, so we can see this on the graph over here. All right, so for part, what this bullet says? If you remember, this is way back from Math 10C, but a mathematical function is a mathematical relation in which every input has only one output. We used a vertical line test to see if a relation is a function. If you draw a vertical line, you should only get one intersection point on the graph. If you get more, the relation is not a function. So if we look at my original graph, which is this parabola opening upwards here, if I draw a vertical line here, this is going to pass my vertical line test. But if I look at the inverse relation, it is failing the vertical line test. So for this part, y equals f of x, yes, is a function. Is x equals f of y a function? No. Okay, so here's what we say for part D. Now, if we come back and we look at our original function, which is this parabola. Now, if I was to do the horizontal line test, I'm going to say that my original graph fails the horizontal line test. Now, that's okay. Functions don't have to pass the horizontal line test. But since an inverse is flipping your x and y, if your original graph fails the horizontal line test, that's going to mean that your inverse relation is going to fail the vertical line test. So when they say restrict the domain of y equals f of x, what it means is we want to make y equals f of x pass the horizontal line test. And the reason we're saying that, so the horizontal line test. So if I take this guy and say, so I'm going to say restrict the domain. So my domain is like, this graph is doing this one, right? It's going like this. Well, if I only graph this half over here, the domain I'm restricting this to is domain is from 0 to infinity, okay? And that means I'm only graphing this part over here. What that's going to mean is that on my inverse relation, I'm only going to be graphing this part over here, okay? It's like, since I'm not graphing the left part, I won't be graphing the bottom part of my inverse over here, okay? So what these type of questions saying when they say restrict the domain of y equals f of x, you want to make y equals f of x pass the horizontal line test. For example 3, restrict the domain of y equals f of x so that x equals f of y is a function. So right, as you can see over here, this function is failing my horizontal line test, okay? Now if I look at this point over here, which is 4, 2, I'm going to say, let's make the domain from 4 to infinity. So if I do this, that means I'm not graphing this part over here all of a sudden, okay? Because it's like I'm eliminating this part here, okay? Now what happens is that this graph is now passing the horizontal line test, therefore my inverse will pass the vertical line test. So f of x passes the horizontal line test. And that's after we've restricted the domain from 4 to infinity. Therefore, x equals f of y will pass the vertical line test. All right, so that's how this guy works over here. Okay, example 4. Determine the equation of the inverse. Y equals 1/3 x minus 4. So here's going to be step number 1. Step number 1 is going to be switch x and y. So if I have y equals 1/3 x minus 4, I'm going to make it x equals 1/3 y minus 4. Okay, so there's my second step is going to be to resolve for y. So resolving for y, I'm going to add a 4 to both sides. And then I'm going to multiply by 3. And I get 3x plus 12 equals y. My last step is going to be this. Relabel as f
Grade 12, you're ready for
inverse
the
of x.
PQR. So PQR grade 12 to the cafeteria.
So what this means over here, this is another way of saying the inverse solved for y. Okay? All right. Part B, same steps. Step 1, x equals square root of y minus 3 minus 2. Next step, add 2 to both sides. Okay, so the inverse step was flipping your x and y, and now we're just going to resolve this equation for y. That's step number 2. Square both sides, so I'm going to square it like this and like this. And therefore, I'm going to get y equals x plus 2 squared plus 3. So that means f inverse of x is x plus 2 squared plus 3. And something's a little bit different what's happened about this guy. If we look at our original function and we graph this guy in our calculator, we're going to see something like this. We're going to cover a unit on radical functions, guys. Sorry, guys, I made a mistake on this. We're going to see this, x minus 3. There we go. Guys, we're going to do a unit on this one later on, and we're going to see this function like this. For the next one, we have x plus 2 squared plus 3. So that means 2 left, up 3. And we're going to have a parabola that looks like this. Now, what I'm hoping you're seeing here is that this graph and this graph are not reflections of each other. Okay, I'm going to say that this part and this part kind of match up, but this part does not exist on this guy over here. Okay, now the reason is so this is my original. My domain is going to be from 3 to infinity, and my range is going to be from -2 to infinity. Now, what we learned in the previous example is when you take the inverse of a function, the domain and range flip. So that means the domain should be the same as this one, which is -2 to infinity, and the range should be 3 to infinity. My range is good here. It goes from 3 to infinity, but my domain is not. So my domain should be -2 to infinity. I'm going to exclude this part here, and now it starts at -2, and it only goes up going this way. Okay, so this answer should be like this, but there should be almost a comma and say that x is greater than or equal to -2. Okay, because that's what this guy should be over here. So we have to have a restricted domain on this parabola over here. Part C. We have, okay, so step number 1. Here's what we'll call it our inverse step. We're flipping our x and our y. Add 3. Square root both sides. And one thing we need to remember, guys, is anytime we square root both sides of an equation, we have to go the plus or minus like this. And then we subtract 1. So we get f inverse of x equals plus or minus square root of x plus 3 minus 1. Okay, and that's how this guy's going to work over here. All right, last example. So for example 5, we have image points with inverses. Okay, so what we're going to do over here, so first of all, if we have y equals f inverse of x, this is the same as x equals f at y, or sometimes we say a reflection in y equals x. Okay, those are all the same thing as inverse. Point being, what happens in inverse? You flip your x and y. So point 5, 15 becomes 15 comma 5. Okay, all right, so look at this guy over here. Pointing out over here is we're going to apply this inverse step first, which means flip x and y. So I'm just going to do this a couple steps. Flip x and y is going to be 15 comma 5. And now we're going 3 left and 2 down. So 3 left would become 12. 2 down would become 3. Okay, so that's going to be our new point over here. All right, so now, same idea. We're going to do our inverse step first. So 5, 15 becomes 15 comma 5. And now, what does this negative 2 do? It multiplies our y coordinate by negative 2. So we're going to have something comma negative 10. And we have a negative x, which means we have a reflection in the y-axis. So we're going to have a negative 15. Oops, let's try this again. This is negative 15, comma, negative 10. And now we're going up 1 because of this guy. So we're going negative 15, negative 9. That's our answer for this guy over here. All right, guys, I hope inverses make sense. And as always, send me a message or let me know if you guys have any more questions. And I will see you in the next video.